Let's start. Good afternoon, everyone. We are Team Effiseekers, and our motto is to seek cost-effective energy solutions. We are solving the problem statement business models for fueling stations of the future. So, without much ado, let us start. Let us first identify the problems we are catering to. First, being the intermittency of renewable energy. The sun does not shine always and the wind does not blow always. So in order to make the renewable energy systems more viable, it is very important to develop low cost energy storage solutions. And the second being, while driving in the city, electric vehicles battery packs are not able to be utilized fully. So these are the problems that we wanted to solve. Also, according to a stat, by 2050, 30% to 45% of annual electricity can be consumer owned, like rooftop solar photovoltaic and battery storage. So the world would be moving towards decentralization of energy and off-grid system. So the product that we are offering is online energy transaction marketplace. So it would be an online platform to trade energy. We wanted to introduce such charging infrastructure using V2G, vehicle to grid, uh, where an EV owner would be able to buy or sell his energy. So our objectives are to accelerate the transition to electric vehicles, introduce a bi-directional power transfer and make the systems viable, like use a car's battery as a mobile energy storage and integrate the energy sector and the mobility sector. Also providing a low cost energy storage option to a building so that the building can be made self-sufficient in its energy needs. Now my friend Tejas will take over.
So, according to a survey, a typical American car drives for 25 to 30 miles each day in a city, but the typical battery pack capacity is 175 to 250 miles. This means that an average battery pack would only be used 10 to 15% daily. This poses a peculiar problem to electric vehicles because, unlike internal combustion engine vehicles, electric vehicles are usually charged every day, and this charge typically comes from an off-grid source like solar or wind panel installed in the owner's home. So this leads to a dead weight of the unused battery pack. And for example, a typical electric vehicle like the Chevy Volt, if only used for 15% of its battery capacity, would mean that 50 kilowatt hours of its battery would go unused every day. Considering that lithium ion batteries are really expensive and in demand, this is a huge loss of opportunity cost and a very poor allocation of resources. The solution to it could be that the owner of this excess energy could trade this energy on the online energy transfer marketplace. This is our business model canvas, and as you can see, our business model is quite compatible with that of Chargepoint, but the key propositions we have added here are that an electric vehicle owner should not be only the one who is consuming electricity, but should also be able to supply electricity. This would give benefit to the electric vehicle owner, as he would be able to get some economic utility out of his battery pack. This would give a benefit to the charging stations, as their dependency on the grid would reduce, and they would be able to attract more customers who are not only consumers of energy but also suppliers of energy. This would be beneficial to ChargePoint because it would be able to cater to a wider base, and it would increase the usage of its typically existing products like ChargePoint card. In future, ChargePoint can also get an additional revenue stream by levying a transaction fee on each energy trade. So this has an effect of building an energy ecosystem based on energy trading, supported by the products and services provided by ChargePoint.
So to conclude, this model can have several implications. ChargePoint can create a niche out of it in the energy market. A vehicle acts as a liability, but through this model, it can turn into an asset for the user with an added revenue source. This would not only make the renewable energy systems more viable, but also encourage more adoption of electric vehicles. And for ChargePoint, it can create another revenue source in the form of transaction fees And Chargepoint can turn out to be a key player in this energy ecosystem.
Okay, thank you very much.
Thank you. Any questions?
I'll move to Q&A.
So do you, Marissa, do you have a question? You unmuted as well. I was formulating.
Yeah, I was also, I was kind of wondering about this idea that Chargepoint would buy the power back from the EV driver. Like, what then would Chargepoint do with it?
Chargepoint won't buy. Well, basically, it would provide charging infrastructures. Like the business would be to provide charging infrastructures, which include vehicle to grid energy, vehicle to grid charging options, technology. So using that, like EV owner would be able to sell his energy to the grid or to a building whenever the demand arises.
And also the energy in charge stations comes from somewhere, right? And mostly it can be from grid, but if a charge point instead buys from an EV owner, he wouldn't be relying on the grid and would be surely getting a clean source of energy. So Chargepoint itself is not buying, but the charging station which uses Chargepoint's services is buying the energy.
And for every transaction, like we would have like a online web-based applications. So for each transaction, like we can charge 1 to 2% transaction fees on that. The Chargepoint can charge on their services, for their services and all, and an added transaction fees for that.
And so would the vehicle owner make a decision about selling their excess energy? Is that how you envision it?
Right.
Yes, we have plans for that. We were like planning to develop algorithms for it. The owner would have an option to he would have a application. He would have a Chargepoint app where he can decide if he wants to sell his energy or not, and he can set certain limits on that. And we also have an option of developing machine learning algorithms by analyzing the traveling patterns of the vehicle owner. The algorithm would analyze the traveling patterns and decide how much energy needs to be stored in the electric vehicle and how much it can afford to sell to the grid. So this would help the owner to decide how much like he can earn by selling back to the grid, and like he can earn in cash or in charge points, energy points. That would be a like credit-based system.
So
Oh, sorry.
Go ahead, Marissa.
Oh, I was just gonna ask, did you look at how much they could earn or like model out any of the actual financial impacts?
We don't have like specific numbers, but we were like seeing like with more penetration of electric vehicles in the markets. Like if we see like 50,000 or 100,000 electric vehicles are charging in a single day, and they are transacting or they are selling their energy. If like 10 kilowatt hour or to 20 kilowatt hour, if a vehicle is selling, then like it is like in the US, I think it is 13 cents
per unit.
It kind of varies the per unit cost. So like for 20 cents, it would like come out to be like it can come out to $10,000 per day for like 50,000 vehicles, and it can increase upon like we can increase those numbers.
Okay, we are out of time.
If you want to explain.
Yeah, thanks. This is
Thank you.
great.
Thank you.
Thanks, team. All right, one last pitch.
Right. Yep.
Woo.
I will admit these guys. I think 2 of them are here
Okay.
so far.